Hello gardeners, welcome to the Living Soil Lab. Walk into any thriving garden and you'll find one common denominator that most gardeners overlook: an underground workforce of earthworms that never clocks out, never complains, and works tirelessly to build the foundation of plant health. These aren't just any garden inhabitants, they're biological engineers that transform your soil structure, cycle nutrients at rates that dwarf what any fertilizer can achieve, and create pathways for water and oxygen to reach plant roots. Every time a worm burrows through your soil, it's aerating compacted earth, mixing organic matter deep into the profile, and depositing nutrient-rich castings that are 5 times richer in nitrogen, 7 times richer in phosphorus, and 11 times richer in potassium than the surrounding soil. But here's what most gardeners miss: worms don't just randomly appear in your garden, they're attracted by specific conditions and particular plants that signal to them, "This is home." Today, I'm taking you on a tour of the exact plants I grow specifically to create an irresistible environment for earthworms, turning my garden into what I like to call a worm paradise where these soil heroes thrive year-round. Let's start with the absolute champion of worm-attracting plants in my garden, Comfrey. This perennial powerhouse isn't just beautiful with its drooping purple flowers, it's a worm magnet for reasons that become obvious once you understand what's happening below ground. Comfrey sends down taproots that can reach 10 feet deep, mining minerals and nutrients from subsoil layers that most garden plants never touch. As these deep roots grow, die back, and regenerate throughout the season, they create organic matter-rich channels deep in the soil that worms follow like highways. But the real magic happens with Comfrey's leaves. They're packed with nitrogen, potassium, and trace minerals, and when they die back or when I harvest them for mulch, they decompose quickly into a feast that worms absolutely devour. I've planted Comfrey strategically around my garden beds, and without fail, the highest worm populations I find are always within 2 feet of these plants. Right next to my Comfrey patches, you'll notice I have clover growing as a living ground cover throughout many of my beds and pathways. White clover and red clover both work beautifully, and the reason is twofold. First, as legumes, these plants host nitrogen-fixing bacteria in their root nodules, and when those roots die back naturally throughout the growing season, they release nitrogen-rich organic matter directly into the soil, exactly what worms need for their protein-rich diet. Second, clover creates an incredibly dense, fibrous root system in the top 6 inches of soil that constantly sheds fine root hairs and exudates. This creates a buffet of organic matter right in the zone where most earthworms feed. I've done informal worm counts, and areas with established clover consistently show 3 to 4 times more worm activity than bare soil just inches away. The third category of worm attractors I grow intentionally are what permaculturists call dynamic accumulators, plants that mine specific nutrients and concentrate them in their tissues. Borage is my favorite in this category, with its striking blue star-shaped flowers that bees adore. Borage accumulates calcium, potassium, and trace minerals in its large, hairy leaves. When these leaves drop naturally, or when I harvest them for mulch, they provide worms with a mineral-rich food source that's different from what most other plants offer, creating dietary diversity that supports larger worm populations. Dandelions, which most people curse as weeds, are another dynamic accumulator I actually cultivate intentionally in designated areas. Their deep taproots pull up iron, copper, and other micronutrients, and their leaves are surprisingly nutritious for worms when they decompose. Now let's talk about the plants that create ideal surface conditions for worm activity, because earthworms don't just eat roots, they're primarily surface feeders that pull organic matter down into their burrows. My leafy greens and brassicas play a crucial role here. Throughout the growing season, plants like kale, collards, chard, and cabbage constantly shed their lower leaves as they grow. Instead of meticulously cleaning these up, I let them fall naturally around the base of the plants. These nutrient-dense leaves create a continuous supply of surface litter that stays moist and breaks down steadily, giving worms a reliable food source right where they need it. The thick stems of brassicas, when I cut them down at the end of their season, also decompose into excellent worm food over several weeks. What many gardeners don't realize is that the size and frequency of leaf drop matters as much as the quantity. This is where certain herbs become incredibly valuable for worm attraction. I grow calendula throughout my garden, and while most people focus on its gorgeous orange flowers or medicinal properties, I'm equally interested in how it constantly drops small leaves and spent flower petals. This frequent small-scale leaf litter is perfect for worms because it doesn't mat down or create anaerobic conditions the way large amounts of grass clippings might. Chamomile serves a similar purpose, with its feathery foliage constantly shedding tiny amounts of organic matter that worms can process quickly. These herbs also tend to self-seed and spread into gaps between larger plants, creating continuous ground cover that keeps soil temperatures moderate and moisture levels stable, both crucial for keeping worms active near the surface. The microclimate these plants create is just as important as the food they provide. Notice how I've allowed these worm-attracting plants to create what looks almost like a living mulch layer. This isn't accidental. During hot weather, bare soil can reach temperatures that drive worms deep underground, where they become dormant and stop providing all those benefits we want. The shade from low-growing herbs and the canopy from larger plants like comfrey keeps the soil surface at temperatures worms prefer, between 50 and 70 degrees Fahrenheit. The dense plant coverage also maintains consistent moisture without the soil becoming waterlogged, creating that perfect damp sponge texture that worms thrive in. In October especially, as temperatures start dropping, these protected microclimates keep worms active much longer than they would be in exposed soil. Let me show you what all this intentional planting actually produces. I'm going to do a simple worm count here near this established comfrey plant by gently digging down about 6 inches and examining 1 cubic foot of soil. Watch as I carefully break apart this soil. There's 1 worm, 2, 3, and I can see several more tunnels indicating recent activity. Compare this to an area of my garden where I haven't yet established these worm-attracting plants, and the difference is stark. In less optimized areas, I might find 1 or 2 worms in the same volume of soil, if any. The goal isn't necessarily to count exact numbers, but to observe the trend. More worms where you've created the right conditions. Beyond just worm bodies, look at the signs of their activity throughout this area. See these small, granular mounds on the soil surface? Those are worm castings, and they're everywhere around my comfrey and clover patches. These castings aren't just any soil. They're essentially pre-digested organic matter mixed with minerals from deeper soil layers, forming the richest natural fertilizer you could ask for. The soil structure here is noticeably different too. It's crumbly and aggregated rather than compacted, with visible pore spaces that allow water to infiltrate quickly while still holding moisture. When I plant into areas with high worm activity, roots establish faster and grow more vigorously because they're moving through this beautifully structured, nutrient-rich medium. The proof of this system's effectiveness shows up most clearly in plant performance. The vegetables I grow in my high worm activity zones consistently outperform the same varieties in other parts of my garden, even when I'm applying the same amendments elsewhere. Tomatoes set more fruit. Leafy greens grow faster and larger, and everything just has that deep green, vigorous appearance that signals optimal nutrition. I've watched plants that were struggling in one location completely transform when I transplanted them to these worm-rich zones. It's not magic. It's simply what happens when you build soil biology to the point where it can actually support plant health the way nature intended. Creating your own worm paradise doesn't require transforming your entire garden overnight. You can just start with 1 or 2 of these worm-attracting plants in an area where you want to build soil fertility. Even a single comfrey plant or a small patch of clover can begin attracting and supporting worms within just a few weeks. The key here is understanding that you're not just planting these species for what they produce above ground. You're cultivating them for the underground ecosystem they create and feed. As your worm population increases, you'll notice the benefits spreading beyond just where these plants grow, because worms are mobile and will gradually colonize adjacent areas as conditions improve. Maintaining a worm-friendly environment requires embracing a few practices that might challenge conventional gardening wisdom. First, reduce or eliminate tillage, because every time you turn soil, you're destroying worm burrows and potentially killing worms directly. Those permanent channels worms create are incredibly valuable for water infiltration and root growth, and, honestly, they take time to establish. Minimize or eliminate chemical pesticides and herbicides, which can be toxic to earthworms even when used according to label directions. Instead, focus on building biological pest control by supporting beneficial insects and maintaining plant health through soil biology. And don't forget to keep adding organic matter to the surface regularly, whether it's through these intentional worm-attracting plants, additional mulch, or compost, because worms need a continuous food supply to maintain population levels. The long-term benefits of fostering a healthy worm population really compound year after year. As worms process organic matter and create castings, they're building humus, that stable form of organic matter that holds nutrients, retains moisture, and creates ideal soil structure. This humus formation is the difference between soil that needs constant inputs and soil that becomes genuinely fertile and self-sustaining. You're not just growing plants, you're cultivating an ecosystem that increasingly takes care of itself. And the beautiful thing is, once you've established this system with the right plants and practices, it becomes easier rather than harder over time. The worms do the work for you, and your job shifts from constantly amending and fertilizing to simply maintaining the conditions that keep your underground workforce thriving. Subscribe to the Living Soil Lab for more practical insights into building truly living soil that works for you rather than against you. We're exploring the connections between plants, soil organisms, and garden success that transform how you think about growing food. Share this video with fellow gardeners who are ready to stop fighting their soil and start cultivating the biological systems that create genuine fertility. Together, we're rediscovering that the best gardens aren't built with products from a store. They're grown from the ground up with knowledge, observation, and respect for the incredible organisms that make it all possible.